everyone, welcome back to my channel EduVibe. In today's lesson, we are starting with the next topic of the unit C, matter as a solution acid basis, which is the percent concentration. Is the grade 11 chemistry, and we're doing the third unit of the grade 11 chemistry. Today, we focus on the percent concentration. In the previous classes, we completed the past solution, solubility, and the molar concentration. This is again the percent concentration, the concentration in percentage. So it's volume by volume, you have a mass by mass or the mass by volume. These are three types of concentration in the percent if you want. So the percent concentration is the measure of the number of units of solute per 100 units of solution. So basically we measure the number of units of the solute, which is per 100 units of the solution. Why is 100? Because we're including the percent in this. If there's a percent, so we divide it by 100, you know that. So that's the thing we take care of. This number of units of the solute per 100 units of solution, and this is called the percent concentration. So where first percent concentration of the mass by volume concentration is the ratio of the mass of solute that is present in a solution related to the volume of the solution as a whole. So we take the mass of the solution and mass of the solute in this and the volume of solution in this and multiply it by 100 to get the mass volume thing. So basically for this we have to, in the question we have to given us the mass of the solute and the volume of solution. So the confusing part in this topic is that you have to have that ability to identify that which is the solute and which is the solution. So that's the thing we have to take care of this, that sometimes it's becoming confusing for you. And the mass by mass concentration is the ratio of the mass of solute that is present in a solution and the mass of the solution. So in the mass, we have a mass of solute again, but divided by now by the mass of solution and multiply by 100. And this involves now solute, mass of solution. You have to identify this in the question. Then we have a volume by volume concentration is the ratio of the volume of solute that is present in a solution related to the volume of the solution as a whole. In this, you have a volume of solute divided by the volume of solution. Always the solute thing is in upper, because solute should be upper always in mass or in the volume. And you have to multiply by 100. So the mass by mass and volume by volume are the same formulas, but we have a difference of mass and volume. But in the mass by volume, we have a mass of solute and divided by the volume of the solution. And all are multiplied by 100. You have to, sometimes they ask that find this, like find mass to volume, mass by volume concentration. But sometimes they can't, like this is said the percent concentration you have to find. So you have to identify sometimes. So the three formulas should be, you have to know in this for doing these examples for this. So the first example we have, the solution contains 140 ml of the pure acetic acid in a 500 ml bottle of solution. What is the percent volume by volume concentration of the acid? They mention you have to just find the volume by volume concentration, which means you have to find the percent volume by volume. So you have to know about volume of solute and the volume of the solution. Multiply by 100. So in this, what is the solute of which is that. So basically the hint is that if you want to find that, identify that which is the solute and which is the solution, but here they mention that thing, this is mentioned, but sometimes if they're not mentioned, you have to know that the thing which is smaller, that 140 ml is smaller, so this is a solute. And 500 ml is the large value than 140, so this is your solution. And they clearly mention that thing over there. Now you just, and make sure that the units are same. If there is a ml, so there should be ml in this too. So you have that 140 ml divided by the 500 ml and multiply by 100. And when you solve this whole thing, you get about 2.80 percent by volume, and volume answer for this. So that's how you can find for the anything. They mention the volume by volume, you can find the anything. And one thing I'm skip over there, that in the mass and mass, like in the volume and volume, have to be liters per liter or ml per liter, ml per liter per ml per liter. And mass and mass, you have to be in kg per kg, grams per grams, or sometimes mg divided by mg. You have to take care of these things. But in the mass and volume, you all be in this either being kg per liters or the grams per milliliter, because these are things are equivalent to each other. So you have to make sure about this. So that's how the volume works. Let's move on to the next example. Now you have to find the mass of the solute in this. To require to prepare the 4.00 liter of oxalic acid with a concentration of the 24% mass by volume. So the hint in that the percent is given to you this time. So you have the mass per volume thing, which means you have 24% mass by volume thing is given. You basically have to find the mass of solute. So which means you have the formula like this: mass of solute divided by the volume of the solution, and they've given us the volume over there, which is 4.00. What you have to do, that 24% should be converted into something, because at 24 we can't directly use this thing. So 24, you have to divide this by 100 because this is in percent. You get 0.24 kgs. You get 0.42 kg. If you can use kgs, this should be per 1 liter, as I mentioned over there. That's why this thing is very important for these type of questions. So make sure this should be in kgs per liter or grams per milliliter. I take with the kgs per liter because the volume is given in the liters. So now your formula is this, and this is equal to the mass per the volume. So what I do over there, we have 0.24 kg per liters, which is the mass and volume, and is equal to, we have to find the mass of the solute multiply the 4.00 liters in this. And yeah, multiply by 100 thing can be go over there. Like if there's a multiply by 100 over there, they goes over there to multiply divide by this, and we did this already over there. So that's the core thing, and that relation we can do with this. We do it separately, or you get the quotient too. So the 100 goes out with that, so you left with 0.24 kgs upon 1 liter. You have to multiply this by 4.00 liter, and you left with the mass of the solute. And when you solve this, you get your mass of the solute of about 0.96 kgs. Should be in kgs because you start with the kgs per liter. And that's your answer for it. And basically that leads to the liter and also cancel out. So that's how you can find the mass of solute. And if you want, if you have like confusion about these things, you can use directly the formula. Ultimately, when you drop this 100 over there, you can divide this by 100. The thing that matter, you have to take care of the units, like kgs per liter you have to use, because this thing is in kgs. It values in milliliters, so you can do the grams per milliliters. Let's do the now last example. So the question says, what is 4.0% mass per volume concentration of hydrogen peroxide as a molar concentration? So basically given as the 4.0% mass per volume thing. And you have to convert this in the molar concentration. So what's the units of molar concentration? Molar concentration units is moles per liters. I will use these units. For the mass per volume thing, you can use either the grams per milliliters, or you can use kgs per liters. So we'll go with the grams per milliliters if you want, but you can go with the kgs per liter if you want. You get the same answer this time. For these type of question, you do the unit analysis. Why the unit analysis? Because these sums can be very difficult somewhat, because you have to do the conversion in this from grams per milliliters to the moles per liters. Basically, as we're doing over there, first you multiply by 100. You have to multiply this by 100. That's 4.0 multiply by 100. We have 0.04 mass and volume. And you take grams per milliliter. So you have to write 0.04 divided by 1 ml. This has to be grams. Now your goal is to cut the grams and milliliters and take the things that which involve the moles and milliliters. Moles should be in the numerator and liters should be in the denominator. So how can we do this? We're given the hydrogen peroxide. So hydrogen peroxide is the thing which we can use in this. So what's the molar mass of this? So you can use the molar mass of this. So it's basically H2O2. So 2 times 1.00 or 1.01 and 2 times 16.00, you will get about 34.02 grams per moles approximately. You want moles in numerator, so you could do 1 mole divided by the 34.02 grams. You want grams in denominator because you have to cut this grams over there. So get rid of the grams now. You have to cut your milliliters too to get the liters. You want in liters and you have to cut the milliliters. So you can use the one thing more, that 1 liter is equal to the 1000 milliliters. You can use this thing. So from here your milliliters cancel out and you get the moles per liter over there. So now you have to just do the calculation, multiply the 0.04 multiply by 1000, divide by 34.02, you will get about 1.2 moles per liters. And that's how you can do the conversion from the grams per milliliter to the grams per milliliter. You get the same answer when you do kgs per liter too. You get the same answer, 1.2. So that's how it works, and you have to take care of all the things in this, that which thing involved in that thing. So that is a unit analysis. For these type of questions, you have to use unit analysis. Not you can get a confusion in the formulas in this if you use. So make sure you use this. So that's all you have to discuss. We all have to discuss this, the personal illustration, how it works, what is unit analysis in that thing which is new. So that's all you have to do. And in the next lesson, we start with the parts per million, parts per million concentration, which is again very calculation based topic, and we involve a unit analysis in that topic very much. So that's all for this lesson. Let me say EduVibe, learn smart not harder. Please like and subscribe to my channel. If you have any questions, let me know in the comment section. See you in the next lesson. Till let's get it with EduVibe.